So this question says, let there is a box on a ramp. So let's draw my ramp first. And there's a box on it. And it says it has a mass of 2.5 kilograms. And it has an angle of 25 degrees. Okay? And so if you consider this box, what are the forces that are acting on it? What are the magnitudes of the weight, normal force, static friction acting on the box? Okay, so we are looking for normal force. We are looking for F static. And we are also looking for its weight. Okay, just by knowing its mass, we should be able to calculate everything, including because we know what the angle is. Okay, what do we know from Newton's laws? We know that normal force acts on this object, and that direction of the normal force is this one. We also know that the weight always acts downward. So if you have a weight here, it will always act downward. So mg always acts downward. Okay? We also know that the static friction will always act opposite to the way this object will move. So if left to its own devices, what will this object do? It will tend to slide down. Okay? So that means that your frictional force is going to be a contact force, and it is going to point upwards. Right? Now, the question arises, what coordinates should we be using? So it has been my experience that in order to solve problems like this, the easiest coordinate system that you can do is something called the tilted coordinate system. Okay? Or at least that's what I like to call it. So I'm just going to use my coordinate system plus x and y this way. So again, I'm going to draw it here so it can become more clear. This is my coordinate system because I chose that to be my coordinate system. Okay? Now, according to this, mg is a vector. And now that needs to be resolved into its components. Okay? This angle always corresponds to the angle that is present here. Okay? So if this is 25 degrees, this angle will also be 25 degrees. So watch very carefully. The magnitude of this force is mg. This will be mg cosine 25 degrees. And this will be mg sine of 25 degrees. Okay? So I'm going to now write my sigma fx and sigma fy. Sigma fx and sigma fy. How many forces acting in the y direction? So my bent tilted coordinate systems are those ones. I have this force, mg sine of 25. Mg sine of 25 degrees. I have a friction that acts upwards, F of s. Note, I didn't put a plus or minus sign. All I did was I collected all the forces that are in my problem and I put them down there as F of x. Now all the forces that are in the y-axis. Okay, I have a normal force. And then I have this component of mg. So I have mg cosine of 25 degrees. Okay? That one. Now comes the question of figuring out which ones are plus and which ones are minus. So sigma fx, mg sine of 25. That force, is it along my chosen coordinates or is it against it? Well, if I'm reading this correctly, it is actually along it. So I'm going to put a plus sign here. Fs is pointing upwards, so that means it's opposite to my choice, so I put a minus sign. I chose my y to be positive upwards. N will be plus, and mg cosine theta will be minus. Okay? That gives me Newton's laws. Okay? Now it's saying that it is static. So it's not moving. Which means this is equals to 0 and this is equals to 0. What am I left with? If I take this to be equation 1 and this to be equation 2, what am I left with? I am left with mg sine of 25 degrees equals f of s. And from this equation, I can write n equals mg cosine of 25 degrees. I know the value of g is 9.8. If I know that the value of g is 9.8, can I plug in m, which is given, 2.5, g, which is 9.8, and sine of 25 to come up with f of s? So, one problem solved. That one we got. N equals mg cosine of 25. Same thing. I know m, I know g, I know 25 cosine. I can plug it into my calculator and come up with an answer. Done. Now the last problem, what is W? What is the weight? Well, that one's actually really easy because weight always is just mg. I have m, I have g, I can plug it in and solve. So here's homework for you. Do it. Come up with answers.